Hello and welcome to another video on R programming. In this video we will take a look at how to append to an existing matrix using the rbind or cbind functions. We'll also take a look at how to index into a matrix, some basic column and row functions that can be used with data which is in matrix form, and finally we'll take a look at how to properly define categorical variables as either being nominal or ordinal. So let's start by defining an example data set. Run this section here, and then let's go on ahead and call up a matrix so we can see what it looks like. So we see that is a 4 by 2, and we have row and column names. This is the same data that we created for previous videos. Now let's say that in addition to these 4 different companies and their 2 quarterly stock prices, that we wish to add another row, let's say for Amazon stock prices. This is where we would like to use the rbind function, because it is going to append new information as new rows. Now what we could do is to use rbind and just simply identify what information we'd want to add, and if we went on ahead and did that, let's see what happens. We can see that it appends a new row of information, but there is no row name associated with that. So on this next line, it's going to be exactly the same as before, but notice that there is an identifier now associated with the information. So if I were to run this, the stock symbol is now identified with those 2 stock prices. So go on ahead and run that so we can update our stocks matrix. Now the next thing I'll take a look at is going to be indexing to a matrix. So what you're going to do is use these brackets. So stocks open bracket with a space, comma 1 closed bracket is going to say that I want the entire first column of information, because we're going to index with rows and then columns. So if we were to run a line, notice that it would just give us the entire first column of information, which would be the first quarter stock prices for all the companies together. Now with the next example, if we were to use open bracket 3 comma space then closed bracket, you'd see that it would give us the entire third row, which is just the 2 quarter 1 and quarter 2 stock prices for Allstate. Now you can also use a colon if you wanted a series of elements. So in the next example provided here, notice that it's going to be giving us the second quarter price for IBM, Microsoft, and Allstate, because they happen to be the first, second, and third rows of that matrix. And if you ever wanted to just pull out a certain subset, then you're going to want to use the concatenate function or combine function. So you can see that if we use C parenthesis 3 comma 5, that it would just give us Allstate and Amazon because they corresponded to the third and fifth rows of information. Now additionally, you can do this type of indexing with matrices by using the row and column names if they've been already attributed to the matrix, which in this case it has. So in all the examples that you see below here are going to be exactly the same thing that you would get from running what we have above. Alright, the next thing I want to take a look at are going to be a couple of commonly used functions when you have your data already in the form of a matrix. 2 of these are going to be the colMeans, colSums, and then the rowMeans and rowSums. And if we were to just run colMeans on the matrix, you would see that it would just give us the mean quarter 1 stock price and the mean quarter 2 stock price, whereas if we ran rowMeans, it would then give us the mean for each company in this case. Now when it comes to performing arithmetic, you're just going to be carrying over what you were doing with indexing. So if we wanted to look at quarterly change, let's say for a company, then you could just take the difference between the second quarter and the first quarter, which would be 2 columns, or you could just multiply everything in a certain column by the same number. Like if you wanted to convert the second quarter prices from US dollars to euros, then at least right now we'd want to multiply everything in that column by 0.91. Or you could take a difference between the 2 columns and then do a element-wise division like what's shown here to come up with the percent change over the 2 quarters. Now let's say that we wanted to actually use that percent change as new information into our matrix. So what we can do is just take that formulation, save it as percent change, and if we pull this up, so I just run this little piece, we can see that we have many decimal places. If we wanted to put this into the matrix and view it, perhaps we'd want to round that to 4 decimal places to make it easier to view before we actually call upon cbind to append that as a new column of information. So I'll go on ahead and use the round function to do that. And then we'll just call that up using the cbind function to append, and we can see what happens now is that we used rbind previously to append the new information for Amazon, and then we used the cbind function to append that new column of information. Go on ahead and run that entire line now so that we can update stocks. Now the last thing we'd like to take a look at here is going to be the 2 ways in which you can define categorical variables. The first we'll take a look at is going to be definition of nominal variables. So first, you need to make sure that you identify this as a character vector. So notice if we wanted to put together the different markets in which these different stocks are associated with, then we could save this as market. Then we could use cbind once again to attach that information to our stocks matrix. And if we do that, notice down in the console what happens. Everything is a character element, which is not going to be a good thing, because now if we try to take the mean of our first column, or Q1 prices, ours is going to return an error. And that's because it can't use something like the mean function on a bunch of characters. Instead, what we have to do is to identify the variable as a factor, which is what we can do here by using the factor function. So market's already character vector, but we'll use factor on it and save that as market. Now whenever we cbind that, notice what happens. Everything that was previously in stocks is going to remain as a numeric vector, or numeric information, I should say. But notice market now is 21211. Now you might think that that is changing the information there, but if we were to run summary on market, notice what happens. It's identifying that 2 with the New York Stock Exchange and the 1 with NASDAQ, so that the information is retained. And if we were to use plot market, we'd see that the information is also retained to be able to create graphics as well, which is something we'll talk about more in a later video. I'm going ahead and update stocks with that information now. And the last thing we'll take a look at is going to be ordinal variables. Now it's going to be very similar to the nominal case, except there's going to be 2 other options within the factors function we'll want to take a look at. Now if I were to go over to the help screen, type in factor, we'll see that the arguments that we're going to be looking at are going to be the ordered option, which we'll mark as being true, because to be an ordinal variable we'd want the order to matter. And then there's also going to be the levels, which we will identify for this one. And the variable we're going to create here is volatility. So it's going to be low, medium, and high. We run this little piece and then take a look at the summary. We'll see that we have low, medium, and high, 2 lows, 2 mediums, 1 high. But in addition to having counts associated with each of our labels, they're going to be kept in order. And a benefit to this is that we could use this as a way to compare different stock prices for the example that we have here. So if we append that information to our existing stocks matrix, call upon stocks, see what that looks like, we'll see that we have that new column of information there at the end for volatility. And let's say that we are interested in comparing Facebook and Microsoft to see if one was more volatile than the other. So if we run this, we'll see that using the information as being ordinal, that it would be comparing Facebook with Microsoft in terms of volatility and returning the fact that Facebook is indeed not as volatile as Microsoft. This concludes the video on matrices. In the next few videos, we will look at other data structures such as data frames and lists. We hope that you have found this video helpful, and happy coding.